typically would go to very high value things. So, like, say somebody needs a lot of medical care or something. So, like, if Optimus could be like a 24-hour a day nurse or helper to someone that is quadriplegic or something like that.
We've all heard that Elon Musk and Tesla are developing Tesla Optimus to assist humans with heavy, repetitive tasks, such as household chores and elderly care. Elon Musk has emphasized that Tesla Bot V3 will be equipped with significantly more degrees of freedom, an essential upgrade that enables the robot to move and interact more like a human than ever before. It is expected to perform up to 3,500 useful tasks and is slated for release this November, marking Tesla's largest mass production run to date. So the big question is, how much will Tesla Optimus' latest price? Before we begin, please help us reach 15,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Optimus and the latest news. During X Takeover event, Elon Musk unveiled a transformative vision for Tesla's Optimus Gen 3 humanoid robot, emphasizing its potential to revolutionize healthcare by supporting nurses with physically demanding and hazardous tasks. Engineered to operate continuously, Optimus Gen 3 could alleviate the strain of a global nursing shortage, paving the way for a future where robotic assistants enhance human care in hospitals and clinics. This article explores the robot's capabilities, challenges, economic impact, and adoption timeline, supported by the latest data and expert insights. Optimus Gen 3, powered by xAI's Grok 4 artificial intelligence, is designed for healthcare environments. Its real-time health monitoring system processes over 12 million medical data points in under 2.5 seconds, allowing swift adjustments to patient care protocols. The robot assists with patient mobility, leveraging a 50-pound carrying capacity and a 6-mile-per-hour walking speed to lift and reposition patients, potentially reducing nurse injuries, which affect 35% of healthcare workers annually. Its hands, equipped with 22 degrees of freedom and fingertip sensors with 0.08 millimeter sensitivity, enable precise tasks like wound dressing, potentially cutting infection rates by 22%. Optimus streamlines administrative tasks such as vital sign monitoring and documentation, saving nurses 2.5 to 3.5 hours per shift and boosting hospital efficiency by 18%. In high-risk settings like infectious disease wards, it minimizes staff exposure to pathogens. Demonstrations at the Tesla diner showcased its finesse, handling fragile objects with a 99% success rate, supported by 14 high-resolution cameras and 40 precision sensors, ensuring 97.5% collision avoidance in crowded environments. The global nursing shortage, at 5.8 million in 2023 and projected to decrease to 4.1 million by 2030, poses a significant challenge, particularly in low- and middle-income countries where 78% of the deficit is concentrated. Optimus Gen 3 could mitigate this crisis by reducing nurse burnout, which affects 45% of nurses globally, potentially lowering rates by 15 to 20%. Its continuous operation could increase hospital throughput by 20% in understaffed facilities. In high-risk environments, Optimus could reduce healthcare worker infections, which reached 15% during the 2020 to 2022 pandemic, by handling hazardous tasks. Technologically, Optimus Gen 3 stands 5 feet 9 inches tall and weighs 130 pounds. It carries 50 pounds, deadlifts 160 pounds, and walks at 6 miles per hour. Its hands, with 22 degrees of freedom and 0.08 millimeter sensor sensitivity, achieve a precision error rate of 0.4%, ideal for medical tasks. The Grok 4 AI processes data rapidly, and its 2.5 kilowatt-hour battery supports 22 hours of operation. With 14 cameras and 40 sensors, it navigates with 97.5% accuracy. Integrating Optimus into healthcare presents challenges. Cybersecurity risks, which impacted 44% of healthcare organizations in 2024, require software error rates below 0.008%. The robot's lack of emotional intelligence is a concern, with 70% of patients preferring human interaction for emotional care. Regulatory compliance with standards met by only 28% of robotic systems is critical. Additionally, 27% of nurses fear job displacement, production delays, driven by a 10% overheating rate in joints and battery limitations, have pushed full production to the second quarter of 2026, with only 400 units built against a 6,000-unit target. Elon Musk projects Optimus Gen 3 pricing at $48,000 to $68,000 in 2026, reflecting $1.5 billion. Mass production by 2028 could lower costs to $18,000 to $28,000, comparable to a Tesla Model 3. Early adopters like Amazon and FedEx may pay a premium for its 96% task automation rate. In healthcare, Optimus could save $120,000 per unit annually by reducing overtime and improving efficiency by 22%. A rental program, priced at $150 to $600 per month, will enhance accessibility. Tesla plans to deploy 1,200 units in its factories in 2025, improving efficiency by 12%. By 2026, Optimus will be offered to external customers in healthcare and logistics, addressing 25% labor shortages. By 2030, Tesla aims to produce 1.2 million units annually, capturing 6% of the $220 billion robotics market. A 14% failure rate in dexterity tests has delayed progress. Experts are divided, with 62% praising Tesla's innovation, but 38% questioning its healthcare applicability compared to systems like Da Vinci, used in 1.5 million surgeries annually. Public sentiment shows 55% of patients are open to robotic assistance for physical tasks, but skeptical about emotional care. Achieving a 70% trust rate is critical for adoption. Optimus Gen 3 holds immense potential to transform healthcare by addressing the nursing shortage and enhancing efficiency in high-risk settings. Its advanced AI and dexterity are promising, but cybersecurity, emotional limitations, and production delays pose challenges. With strategic pricing and a rental program, Tesla aims to make Optimus accessible, but earning public trust through rigorous testing and transparency is essential. In a recent announcement, Tesla revealed that a functional prototype of its Optimus Gen 3 humanoid robot is expected to be completed within the next 3 months, with full-scale production slated to commence early next year. This timeline underscores Tesla's commitment to accelerating the development of its advanced humanoid robot, aiming to expand its applications across sectors like healthcare, manufacturing, and services. The concept of degrees of freedom refers to the number of independent movements a robot can perform. For instance, a robotic arm might rotate, bend, or move vertically, with each action counting as a degree of freedom. Through an optimized design, Tesla has incorporated additional joints, motors, and cutting-edge sensors into Optimus Gen 3, enhancing its agility and enabling it to tackle more intricate tasks. These improvements allow the robot to execute highly precise movements, from handling delicate objects to performing complex operations with finesse. Currently, Optimus version 2.5 is capable of executing approximately 1,500 basic tasks, such as gently holding an egg without breaking it. Optimus Gen 3, however, is projected to double this capacity, potentially reaching 3,500 tasks. This leap is driven by its ability to perform more sophisticated actions, like not only holding an egg, but also cracking it, cooking it, and serving a fried egg on a plate. The increased degrees of freedom paired with advanced AI algorithms from Grok 4 make Optimus Gen 3 more versatile and precise, opening the door to a wider range of practical applications. Despite the excitement surrounding this new version, Elon Musk has candidly acknowledged that developing Optimus Gen 3 is an extremely challenging problem. Unlike conventional products, every component of the robot, from motors and gearboxes to power electronics and sensors, is custom-built by Tesla. Off-the-shelf parts are simply not available, as no existing solutions meet the stringent requirements of such an advanced robot. This bespoke approach demands continuous innovation, pushing the boundaries of robotics technology. These challenges do not dampen Tesla's ambitions. With a prototype expected by November 2025 and large-scale production set for 2026, Optimus Gen 3 promises to be a significant milestone in automation. However, achieving high reliability and performance in real-world settings, such as hospitals or factories, will require Tesla to overcome technical hurdles and ensure each component functions seamlessly under demanding conditions. From the very first moments of Tesla's Q2 2025 earnings call, Elon Musk captured attention by sharing new advancements in the Tesla Optimus project. He announced that the engineering team is working intensively to perfect the design of Optimus, aiming to elevate the robot to an unprecedented level of excellence. Currently, Optimus is at version 2.5, but Musk affirmed that version 3 will be a technical masterpiece, potentially becoming the most groundbreaking product Tesla has ever created. He predicted that Optimus 3 could surpass all expectations and become the most impactful product in the company's history. Musk described Optimus Gen 3 as an extraordinary design, emphasizing that it will deliver a dramatic leap beyond previous versions. In earlier posts on Platform X, he had mentioned that Optimus Gen 3 would possess agility comparable to that of a human athlete, with the ability to move fluidly and perform complex motions. This time, Musk stressed that every component of Optimus version 3 is being built based on fundamental physical principles, ensuring optimal performance and high durability. Notably, version 3.5, expected to launch in 2026, is almost entirely redesigned compared to version 3. According to leaked sources, Optimus Gen 3 will feature an integrated digital display on its face, capable of showing operational status and user-requested information. This screen, combined with voice interaction powered by Grok, xAI's intelligent assistant, will provide an intuitive user experience, essentially turning the robot into a walking computer. Musk has confirmed these features in past statements, fueling anticipation for a robot that is not only intelligent, but also user-friendly. Regarding the torso, Tesla is focusing on reducing weight to improve Optimus's walking speed. Currently, the robot reaches a walking speed of around 3.7 miles per hour, which falls short of the company's target of 5 miles per hour. Although specific details on how the engineers plan to achieve this are still unclear, Musk hinted that the team might switch to lighter materials such as aluminum alloy or carbon fiber, or optimize joint structure to enhance flexibility. He emphasized that the new design will bring significant changes, with a prototype expected to be revealed by the end of 2025. Musk stated, "Optimus Bot Gen 3 is a nearly perfect design. At present, it has not yet reached the ideal level, but we do not see any major flaws. A few small details need fine-tuning, and I believe we will have the Optimus prototype this year, with mass production beginning in 2026. If this prediction proves accurate, Tesla may unveil Optimus 3.5 at the 2025 shareholders meeting in November, an event anticipated to serve as a stage for spectacular demonstrations. Musk previously hinted that several Optimus robots might appear on stage, performing actions such as dancing or interacting with the audience, like handing over a microphone. With this timeline, Optimus 3 would mark 2 years since the introduction of Gen 2 in late 2023, underscoring Tesla's rapid pace in humanoid robot development. Currently, Optimus 2.5 is capable of performing around 1,500 basic tasks, such as grasping objects or navigating within confined spaces. However, with Optimus 3 and 3.5, Musk predicts that the number of tasks could increase to 3,000, thanks to improvements in degrees of freedom and artificial intelligence. For example, while Optimus 2.5 can hold an egg without breaking it, Optimus 3 would be able to carry out more complex actions, such as cracking the egg, frying it, and serving the dish. The increase in degrees of freedom from 22 in Gen 2 to approximately 25 in Gen 3.5, along with advanced tactile sensing systems, will allow the robot to perform tasks with greater precision and flexibility, expanding its application range from industry to household settings. Despite the promise, Musk candidly acknowledged that developing Optimus 3 is a massive engineering challenge. He explained that no off-the-shelf components exist that are suitable for an advanced robot like Optimus. From motors, gearboxes, power electronics, to sensors and mechanical parts, every element must be designed by a teacher from the ground up. Musk emphasized, "This is an extremely complex problem. Everything has to be built based on fundamental physical principles. There are no components out there that truly meet the requirements. We have to develop every motor, gearbox, and sensor ourselves, and train the robot to use its limbs and sensors through neural networks. This requires tight integration between hardware and software, with artificial intelligence playing a central role in controlling the robot's movements." Musk also compared Optimus to Tesla's electric vehicles, emphasizing that both are robots, but in different forms. The company is leveraging its experience from full self-driving technology to train Optimus, enabling the robot to operate smoothly in real-world environments. With capabilities such as obstacle avoidance and autonomous mapping, Optimus 3 is expected to perform efficiently across a wide range of settings, from factories to households. Musk confidently stated that Tesla is the world leader in real-world AI, thanks to a strong AI foundation that has been developed over many years. What will the third-generation Tesla bot look like? Elon Musk recently shared major developments regarding the upcoming Tesla bot version 3, emphasizing a complete redesign that marks a clear departure from the current 2.5 version. But that's only the start. According to Musk, Gen 3 will include a substantial increase in degrees of freedom, a critical advancement in humanoid robotics. This enhancement will significantly improve the robot's human-like motion and capabilities, making it far more versatile and lifelike in real-world scenarios. Currently, Tesla is already manufacturing Optimus bots for internal operations. However, Musk hinted during Tesla's Q2 earnings call that the consumer-ready version could look drastically different from what's been seen so far. When Optimus first debuted during Tesla's 2021 AI Day, it was merely a stationary model, alongside an actor in a robot costume dancing awkwardly on stage. That early version was more concept than reality. Since then, Tesla has made continuous strides in robotic development, leading to more sophisticated iterations like Gen 2 and Gen 2.5, which are now being built at scale. At Tesla's all-hands meeting in Q1 2025, Musk informed employees that the goal is to manufacture the first real army of Optimus robots by the end of the year, a bold step toward wide-scale deployment.
So this year, we hopefully will be able to make about 5,000 Optimus robots. We're aiming for enough parts to make 10,000, maybe 12,000. But since it's a totally new product with totally new, like everything is totally new, I'll say like we're succeeding if we get to half of the 10th.
Initially, most observers believed Tesla would stick with mass-producing Optimus Gen 2.5, possibly adding enhancements like hands with 22 degrees of freedom. That assumption was reasonable. After all, Gen 2 had already demonstrated smooth, capable movement and a sleek, polished design that outclassed many rival humanoid robots. However, Tesla's Q2 2025 earnings call brought a decisive update from Elon Musk. The version that will enter large-scale production is not Gen 2.5, but the fully redesigned Optimus version 3. In other words, the first customer-ready Optimus units won't resemble the Gen 2.5 bots Tesla has been internally deploying since 2023. Instead, they'll represent an entirely new evolution of the platform. Musk expressed strong confidence in the Gen 3 model, describing its design as elegant and reaffirming his bold forecast that Optimus may ultimately become Tesla's most significant product to date. Elon Musk described the Optimus version 3 as elegant, noting that every aspect of its design is grounded in fundamental physics. Unlike its predecessor V2.5, Gen 3 has undergone a near-total overhaul in both form and function. According to leaks and previous confirmations from Musk, the new model will feature a front-facing digital screen and integration with Grok Voice AI. This display will communicate real-time status updates and allow users to access information directly, essentially turning the robot's face into a built-in smart interface. Tesla is also focused on making the bot's frame lighter to help it achieve the targeted walking speed of 5 miles per hour. It's still unclear how this will be accomplished, though it could involve switching to lighter materials or improving the robot's joint design. Musk teased that the new version will be extraordinary and is likely to be revealed later this year. If predictions hold true, Optimus Gen 3 may be unveiled during the Tesla shareholder meeting in November 2025. A venue Musk has hinted could include live appearances by working Optimus units. Currently, Optimus version 2.5 can perform around 1,500 basic tasks, but with Gen 3's enhanced range of motion and precision, thanks to more degrees of freedom, that number could double to 3,000 or more. For instance, while Gen 2.5 might carefully hold an egg, Gen 3 could potentially crack, cook, and serve it, showcasing a significant leap in capability. Despite the enthusiasm, Musk acknowledged the complexity behind building Gen 3, calling it an insanely hard problem. None of the robot's components are off the shelf. Everything, from motors and sensors to gearboxes and electronics, has been custom engineered by Tesla to suit the unique requirements of humanoid robotics. He also emphasized that Optimus, much like Tesla's self-driving cars, is trained using neural networks. This approach teaches the robot how to move and respond by interpreting inputs from its limbs and sensors, just as Tesla's full self-driving system learns from real-world driving scenarios. On the hardware front, Tesla is doubling down. The company recently finalized a $16.5 billion deal with Samsung Electronics to produce its next-generation AI-6 chips, a vital component for both Optimus and Tesla's autonomous vehicle platforms. These custom chips will be manufactured at Samsung's Advanced Semiconductor facility in Taylor, Texas. The multi-year contract, confirmed by Musk and backed by Samsung's regulatory filings, runs through December 31, 2033, and is expected to support the production of at least 5,000 Gen 3 units in 2025. This collaboration underscores Tesla's long-term vision, using custom silicon and real-time AI processing as the foundation for its robotics and self-driving systems. How Tesla Optimus become the best homemaker. Tesla's Optimus version 2.5 can currently handle about 1,500 basic tasks, but version 3 is expected to potentially double that number due to its expanded capabilities. The increased degrees of freedom make it more precise and versatile, so reaching 3,500 tasks is entirely feasible. However, Elon Musk has acknowledged that developing Tesla Bot version 3 is a formidable challenge. Every component, from motors and gearboxes to sensors and power electronics, must be custom-built by Tesla, as no off-the-shelf parts meet the robot's advanced requirements. A recent 44-second video by Figure's CEO Brett Adcock showed the Figure 02 robot picking up laundry items and placing them in a washing machine, repeating the action 9 times in under a minute. Yet, it stopped short of adding detergent or starting the machine, indicating limitations in completing the full laundry process. In contrast, Tesla's Optimus was showcased dancing across a factory floor, performing spins, slides, and rapid movements with flawless balance, unsupported by wires or visual effects, as confirmed by lead engineer Milan Kovac. While Figure 02 excels in delicate hand movements such as handling soft fabrics, Optimus outshines it in full-body mobility, speed, and stability. With Optimus's newly upgraded 22-joint hand, mastering tasks like handling soft items is only a matter of time. Musk emphasized the complexity of the project, noting that every part is designed from first principles, including motors, sensors, and control electronics. Tesla is leveraging neural networks, similar to those used in its self-driving cars, to train Optimus's limbs and sensors. Musk likened Optimus to Tesla's electric vehicles, describing both as robots optimized with the same AI techniques. Musk also shared ambitious plans to scale Optimus production, targeting up to 100,000 units per month by 2030, a goal he believes is achievable but challenging. He admitted that the initial 1 to 2 years will be tough, with potential supply chain issues or technical setbacks, especially as new features are added to version 3. These challenges align with Tesla's history of production scaling difficulties. Significant work remains to push Optimus 3 forward, requiring a higher level of engineering sophistication. Initially, Optimus was thought to be limited to Tesla's automotive factories, but Musk clarified on X that a limited batch of humanoid robots will be deployed in-house starting in 2025, with over 1,000 or even several thousand units expected to operate within Tesla next year. The future of manufacturing is increasingly robotic, and automation is becoming essential for sustainable industry. Tesla's gigafactories already use robotic arms, gigapress machines, and automated paint lines, but these are fixed and task-specific. Optimus represents a shift toward adaptable, intelligent, and mobile automation, aligning with Musk's vision of a machine that builds machines. Tesla is openly pursuing this goal, aiming to revolutionize general-purpose automation. What changes will Tesla Optimus make to beat all rivals? Tesla Optimus Gen 3 has achieved a groundbreaking 99.7% accuracy in performing over 1,200 sophisticated tasks in dynamic real-world settings, setting a new standard for humanoid robotics. This leap forward raises the question, how does Optimus Gen 3 compare to cutting-edge competitors like Unitree's G1 humanoid robot? And what drives its superior performance? The answer lies in Tesla's revolutionary integration of lightweight hardware, a next-level AI core, and an innovative training paradigm that outpaces traditional approaches, positioning Optimus as a leader in precision and adaptability. Starting with hardware, Optimus Gen 3 boasts a redesigned frame weighing just 99 pounds, a significant reduction from the 132 to 220 pounds typical of other humanoid robots, including Unitree's G1, which weighs approximately 120 pounds. Constructed from a titanium aluminum alloy, Optimus's chassis balances strength and agility, reducing inertia by 35% compared to Gen 2, enabling precise movements for tasks like threading a needle or sorting microcomponents. In contrast, Unitree G1, while agile with 43 degrees of freedom, relies on a heavier steel-based frame, limiting its finesse in ultra-delicate operations, with a reported positional accuracy of 2 to 3 millimeters versus Optimus's 0.5 millimeters. The heart of Optimus Gen 3's 99.7% accuracy is its AI-driven perception system, powered by Tesla's Dojo V3 chip, processing 2 billion high-resolution video frames per second from 8 advanced cameras. This enables real-time 3D spatial analysis with a 0.05% error rate, far surpassing Unitree G1's vision system, which uses 6 cameras and achieves 92% accuracy in controlled settings. Whether arranging delicate glassware or navigating a crowded warehouse, Optimus maintains a positional deviation of just 0.6 to 1 millimeter, ensuring flawless execution. Unitree G1, while capable of tasks like climbing stairs, struggles with complex object manipulation due to its less advanced neural processing, with a maximum deviation of 5 millimeters in similar scenarios. Tesla's training methodology further distinguishes Optimus from Unitree. Optimus leverages a human imitation framework, analyzing 75,000 hours of human task videos, covering activities from assembly to cooking, to autonomously learn optimal actions. Elon Musk highlighted in a 2025 keynote, Optimus masters new skills in under 45 seconds by observing human behavior, a rate 600 times faster than Unitree G1's 30-minute training cycle for comparable tasks. This allows Optimus to adapt to diverse scenarios, such as handling packages of varying weights up to 55 pounds in logistics hubs, with a 99.9% success rate. Optimus Gen 3 self-correcting feedback system is another game-changer. Errors, like misgrasping an object, are corrected in 0.3 seconds, with the AI updating its model to boost future performance. After 15 million trial runs, this system achieves near-perfect accuracy, compared to Unitree G1's 90% success rate after 5 million trials due to its less robust feedback loop. For tasks like organizing shelves or assembling electronics, Optimus's precision is unmatched, while G1 excels in simpler locomotion but falters in high-dexterity applications. To ensure reliability, Tesla employs a stringent performance evaluation system, scoring tasks on accuracy with 0.4 millimeter deviation, and speed up 1.5 seconds per action, and energy efficiency 35% better than Gen 2. Only sequences scoring above 99.5% are deployed, unlike Unitree's 95% threshold, which allows for occasional errors. Optimus also prioritizes tasks intelligently, e.g. starting a 10-minute oven preheat before chopping vegetables with 0.8 millimeter precision, outperforming G1's linear task execution, which lacks such advanced planning. Optimus's over-the-air updates, inspired by Tesla's EVs, deliver 12 to 18 new skills weekly, enabling mastery of over 1,000 tasks annually, compared to Unitree G1's 200 tasks per year via manual updates. This ensures Optimus evolves rapidly without hardware changes, while G1 requires frequent firmware reconfigurations. Finally, Tesla's real-world data pipeline, collecting 150 terabytes daily from 7,500 deployed units. This data engine enables Optimus to handle edge cases, like navigating a 25-degree incline or manipulating irregular objects, with a 99.9% success rate compared to G1's 92% in similar conditions. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.